All right, welcome back to part two. Here we go, part two of the test. Also, this is a choose three of the following four questions. Make sure you just choose three of the questions. Okay, so for this one, we're looking for the perimeter of one of the small rectangles. So we're assuming that all of these rectangles are congruent, and that's a fair assumption to make. So we're saying that all of these rectangles are equal. And what you want to know is what the perimeter of one of these rectangles is, okay? So a little bit tricky at the start, but just look at it this way. How can you get to 13 knowing that these two parts have to be equal, okay? And then what would you have left? So if I said that this was 2 and 2, it could be 2, 2, and then this would be 9. This length could be 9, okay? But then you have to plug that in and see if that works with your 33 here, okay? So actually what it came out to be was that this was 3, this was 3, and if these are both 3, you have 6, and you're left with 7 here. So if this rectangle and this rectangle are congruent, then we're saying that this is 7, that's 3, and that's 3. You're just adding them up. P equals 3 plus 7 plus 7 plus 3, or you could say P equals 2 times 3 plus 2 times 7. So your perimeter is equal to 20 centimeters in total. For this one here, a rectangle has a height that measures 4 units and a perimeter of 42 units. What is the base measurement? So if we're saying that, if we use that original formula back there, we're saying that 2 times the base plus 2 times the height. And so we know a couple of these things, and perimeter equals. So my perimeter is actually 42 units. My base is unknown, so 2b plus 2 times 4. So if I'm saying 42 equals 2b plus 8, and I come over here, if I subtract that 8 from here, then I know that I have whatever this number is remaining. So 42 minus 8 equals 36. 36, is that right, Mr. Moore?
34.
34, thank you. That's why we pay Mr. Moore the big bucks. Didn't sound right in my head. It was 34. So I know that this plus this has to equal 34. If I divide that by 2, then I get 17. So if I add these up now and I plug that into 17, 17 and 4, 4 and 4 is 8, 17 and 17 is 34, 8 plus 34 equals my perimeter of 42. Therefore, the base is 17 units. Okay? So for this one here, a rectangle has a height that measures 4 units and a base of 8 units. What is the area of the shaded region? A couple different ways to look at this. The most basic way is just take the area of this rectangle and then subtract the area of this triangle. And you have all the information you need here to solve that. So first off, let's get the area of the rectangle. Area equals base times height. Area equals 8 times 4. Area equals 32 units. Okay, and then my triangle, I know that area of triangle is area equals base times height divided by 2, which is basically just the rectangle, a rectangle cut in half. And we know that every triangle is the other half of a rectangle or a square, or just call it a parallelogram. So there would be the other half, so we divide it by 2. So I have my base is 8, area equals 8. My height doesn't jump right out at me, but if I take this line and if I were to move it across and have it to be still a parallel line, it would actually be parallel to that point here, giving us a right angle, which would give us the height of the triangle. So I know that the height is equal to 4. So 8 times 4 divided by 2, area equals 32 over 2, area equals 16 units squared. So if my triangle is 16 and my whole rectangle is 32, it's just simple subtraction. 32 minus 16 equals 16 units squared. So therefore, the shaded area is 16 units squared. All right. Finally, we have a triangular prism that has a volume of 120 meters cubed. The triangular face has a base of 4 meters and a height of 3 meters. What is the depth of the prism? So what's this amount here? Again, this is just a little bit of reverse engineering and some backwards planning. We didn't actually do a lot of work on triangular prisms. However, you knew how to calculate rectangular prisms. Just apply that knowledge. So if you found the area of the face and you multiplied it by the depth, then you would have the volume of that triangle. So if I'm saying that the formula for this face is area equals base times height divided by 2, plug in the information you know, 3 times 4 divided by 2, area equals 12, divided by 2, area equals 6. So if this is equal to 6 meters squared, and I know that 120 is my volume, so volume equals 6 times d, right? The area of this times the depth. My volume is 120 equals 6 times d. So how would I figure out what d is? Well, if I know that 6 times this equals this, I can just take 120 and divide it by 6, and that will give me d. So 120 divided by 6 equals 20. Therefore, the depth equals 20 meters squared. Now the bonus question here, or the extension question here, is what would be the volume in centimeters cubed? This is straight from your math journals. We spent a lot of time in class talking about conversions from standard units to square units to cubic units. So if it's, the depth is 20 meters, not squared or cubed. So if my whole volume is 120 meters cubed, and I want to go to centimeters, am I multiplying or dividing? I'm multiplying. There's more centimeters in a meter, right? 1 meter has 100 centimeters in it. The measurement is the same. The amount of centimeters is bigger because it's a smaller unit. So the conversion from centimeters to meters is, meters to centimeters is times 100. If I go meters squared to centimeters squared, I'm now saying, well, it's not just one dimension, I'm going this way as well. I'm adding another dimension. So it's 100 times 100. It's times 10,000. And then if I'm going to cubic meters, I've added another dimension. I'm going back. It's times another 100. So to go from meters cubed to centimeters cubed, it's times 1,000,000. There's 1,000,000 cubic centimeters in 1 cubic meter. So for this, I would just times it by 1,000,000. So this would be 120 million. Now, this was straight out of your math journals. We had a chart in our math journals. We spent time with that. So it's 120 million centimeters cubed, which is a lot. That's a lot of cubic centimeters. Gentlemen, that is it for part 2. Part 3 was individual. All of you had individual answers on this test. So when we conference, Mr. Moore, Ms. Murtaugh, or I will talk to you about the various answers that you came up with for this question. Thank you for tuning in. Correct your test tonight, and we will do conferencing tomorrow in class.